Welcome to this session on climate resilient green infrastructure. So here in South Africa, as I'm sure across most of the globe, we've become acutely aware of the impact of climate change with an increased frequency and severity of things like fires and floods. So this has highlighted the need not only for resilient infrastructure that can withstand the impacts, but also infrastructure that can mitigate against the causes of climate change. And so while green buildings can be described in a nutshell as buildings that have minimal impact on the environment in terms of resource use, emissions, and disruption of biodiversity, we're recognizing that green building needs to go beyond the building itself. We need to look way back in the early stages of the value chain at the materials that we use, how they are extracted and manufactured, as well as beyond the building and the site to urban planning, landscaping. So today we have quite a range of speakers and topics that look at the full spectrum of the built environment and new approaches to look at how we design our buildings and our urban areas. We've got a packed program this morning. We've got 6 speakers, and they're going to be looking at, as I said, a range of topics. Each speaker will have 12 minutes to present, and then there will be a time for questions at the end. I ask you to please save your questions for the end. Please do ask questions at the end, and keep your questions to be questions and not an opportunity for you to present your work. Sometimes when questions are asked, they're not really questions, it's just a whole separate presentation. If you do feel that you have something that you want to share, please do come speak to me afterwards, because we can easily arrange a follow-up webinar to this conference where we can have a session to discuss these topics further and in more detail. There's nothing stopping us from doing that. So come chat to me about that afterwards. And if you don't have time to have all your questions answered, then I'm sure you'll be able to catch the speakers in the tea break or the lunch break. Okay. So with that, I'd like to introduce our first speaker, Dr. Peter de Jager. Peter is the CEO of the South African Institute of Architects. She's a registered professional architect and holds a PhD at the University of Witwatersrand. Her expertise spans evidence-informed approaches to promoting health and wellness in buildings, sustainable energy use, and climate-responsive design. Peter worked as an impact area manager at the CSIR here, successfully completing numerous projects. She has lectured and published extensively on healthcare infrastructure sustainability and serves on the UK Research and Innovation International Development Peer Review College. Peter will be presenting on the next frontier, the pathway to low carbon buildings. Welcome, Peter.
Thank you for the introduction, and also you're great honor to be speaking to you today on a topic very dear to my heart, which is around the building sector in South Africa. To me, it's a paradox that we need to think about, because if you look at us as a built environment in South Africa, you might think that we are actually excelling in terms of our carbon reductions. And I'm going to argue today that that's not a good thing. The global building sector has subscribed to the Paris Agreement, which has got the goal of global net zero carbon emissions by 2050. And the built environment contributes significantly to the issue, with 21% of global greenhouse gases being 12 gigatons or so carbon dioxide equivalent being dispensed into the air through our industry. It accounts for 34% of global energy demand, somewhere between 34 and 37%, and accounts for 37% of CO2 emissions, both through energy and process-related emissions. If we want to reach our 2030 interim targets, we're going to have to ramp up efforts by 10 times. In other words, the gap between the current and the desired state of decarbonization in our sector is significant. So just to step back a little bit and have a look at what constitutes CO2 emissions. As mentioned, other sectors across the full spectrum account for about 61% of emissions. and with the balance being attributable through and to the built environment. 11% of that is through embodied energy, which is when you manufacture materials or you construct a building or a road or whatever, the materials that go into that are the embodied constitution of energy. And then when you dispose of a building at the end of its life cycle, that is also part of what is considered embodied. Operational energy is the energy which is accounted for through the use of a building. So the lights being on, the appliances you use, etc. And most of the efforts at decarbonizing our built environment have been through this low-hanging fruit, addressing, low emission light bulbs, dimmable switches, etc. So a big opportunity for us is now to look at the materials, the downstream issues in the built environment, and how we construct the built environment. So the mantra across many thinkers about how you approach this is sort of like the waste management approach. You prevent the use of these materials in the first instance, reduce and optimize the use wherever possible. It's through when you're doing your construction, etc. Planning for the future, and as a method of last resort, offsetting. And there are multiple ways in which we in the built environment can address these things. Here are some example strategies, and there is a contribution to the net zero carbon contribution. And these nicely align with many of the Sustainable Development Goals, which is the reference of this conference. In South Africa, we have already done a lot of things. Much work has already been done. So we can celebrate the Green Book, our eco-label standards, SANS 10400 Part XA, and energy performance certificates, where government is leading by example and labeling buildings as if they were appliances with these beautiful colors. The net zero carbon buildings policies, and much more. So the question is, what is our readiness for adopting these? What is our knowledge about these things? And of course, we can't do any of this alone. It depends on networks and organizations and all stakeholders across all sectors of society cooperating and being on the same page. So just to go back to the Green Book on the previous page, amazing resource. So many people in the built environment profession do not even know about. So we can't be having beautiful policies, beautiful tools, and then it comes to nothing if the built environment professionals who need to use them are not even aware that they exist. So it needs that whole collaborative ecosystem, and I think Luan will talk about ecosystems later. So I'd like to report back on a research project which Dr. Coralie van Reenen undertook recently as part of the CIB task group, which looked at readiness within built environment across several nations. This maps out the participating nations of this survey. I mentioned at the beginning of my talk that we could say the built environment professions in South Africa are doing exceptionally well compared to other parts of the world, because depending on who you read, we are only emitting about 15% of greenhouse gas emissions. Now, whether that is a credible figure, exactly how that is constituted, is not entirely apparent from the literature. So we need to improve our credibility around those figures and what have you. But now I'm going to show you how ready we are to ramp up. Remember, we're going to need to move from looking at the operational carbon to the embodied carbon, and how ready are we as the built environment to address that. So a look at the survey respondents is quite telling. The survey was distributed through all the regulatory authorities to all built environment actors. And the responses in South Africa was that that the greatest bulk of respondents were from the field of architecture. That isn't the case from the other countries, which is a very fascinating thing. Of course, the person who led the survey is an architect, so you would think, okay, maybe there was some bias there. However, there are 10 times more engineers in South Africa than there are architects. So one wonders, where are the engineers in responding to this? And second interesting thing about the survey respondents from the South African cohort is that most of them are old guys, 20 plus years in the industry. And that, because climate change is essentially a future-proofing exercise, that is also a really interesting and important observation. The survey asked people what tools they have and use for, in the top instance, operational carbon, and in the lower instance, embodied carbon. And most of the tools that were listed had never been used by built environment professionals responding to the survey, with, as you can see, others being rarely, sometimes, mostly, or always used. We're not using the modeling tools available at the early stages of planning because maybe we don't know about them. So then asking satisfaction with tools or availability of local data become banal questions if we don't know about them, but there seem to be enabling factors and barriers to utilizing these tools, which this survey has very nicely identified. Why are we doing well? We're doing well in the sense that much of what we do in the built environment is taught to us, and we don't call it addressing carbon reduction. And how you read this is these are strategies. There are 2 slides of strategies for reducing carbon, and on the left is never used, is the dark purple, and yellow is you always use it. And you can see there are clusters of things which built environment professionals always use. They always orientate the building in the correct direction. They're always managing the ventilation, the daylighting, and are conscious of the materials that they are using, and so on. So there's a lot of things that we are doing correctly, but there are a lot of things we've never even heard of that are on the horizon for us to tackle and grapple with. Again, a second slide of these. I'm not going to go through them in the interest of time, but happy to share these, which give us some insight into the state of our built environment profession. This is a beautiful building. It has been completed in Beaufort West through the offices of Harvey Fagan, and it embodies many of these principles that I've showed you are always used in the built environment. It's got a subfloor rock collector, which cools air, trome walls which emit air. It uses natural ventilation. The floor plate allows for cross ventilation. There's earth-packed rammed earth walls. So it is an exquisite response to a very difficult site. We have the technologies and sometimes the expertise to apply really beautiful materials and approaches to building design. And this is another reason that we are doing so very well in South Africa. However, one of the main reasons we're not doing very well is we don't invest in the built environment. And if you go outside and look at the state of our infrastructure, that is patently obvious. And this brings us to our paradox. We have a growing population in South Africa. And with it, we are getting a backlog of units, for example, in healthcare, in education, in classrooms, in housing stock units. This drives informality, which one can argue is not conducive to a good quality of life necessarily, or comfort or health. Despite the fact that our construction sector is shrinking, 3.8% in the last quarter, its contribution to GDP is absolutely significant. If we don't build, we fuel expansion of informal settlements. So we have to build anyway. It's just that the built environment professionals are not involved. Infrastructure is, in any case, the backbone of service delivery. Infrastructure is an investment, socio-economic multiplier. For every rand we spend, it leverages 3 in the economy. It employs 1.2 million people and contributed 110 billion rand to the economy, to the fiscus. So the construction contributes 4.5% to real GDP. The point of my presentation is that if not building is not an option, and to me it is not an option, and the current practice is not sustainable, then transformation of our industry is required.
Thank you very much for that, Peter. Our next speaker is Llewellyn van Wyk, all the way from New Zealand, but also a CSIR alumnus. Llewellyn is a researcher, guest lecturer, and designer with extensive international experience and a leading scholar of 21st century ecological design discourse and supporting innovative building and infrastructure technologies. While residing in Auckland, New Zealand, he is part-time lecturer at the University of Johannesburg, Department of Mechanical Engineering Sciences, and also supervises postgraduate students at a master's and doctoral level. He holds a Bachelor of Architecture degree and a Master's in Science. Llewellyn will be presenting on zoning for resilience, and we look forward to your presentation. Thank you.
Thanks, Coralie, and thanks for inviting me. It's really been a wonderful experience to be back home in a way. Yeah. Okay, so I'm very nervous of the time. I want to talk about something that I'm working on, symbo-urbanism, and what the heck that might be. And it's based on 2 provocations, essentially. The first is a really interesting comment made by Qureshi from World Economic Forum that essentially acknowledges that we have this challenge around climate action and infrastructure development. And the argument is that with the right approach, we can actually achieve both of them sustainably. Now, the magic there is what's the right approach? Something that's been troubling me since that statement was made in 2016. The second provocation is by yours truly, and that is a sense, with almost very few exceptions, that the modern state is not capable of sustainably maintaining its inherited infrastructure. So we sit with this combative situation between the need to build and the need to converse with climate, and they're actually not helping each other. The problem statement would be, and if there's ever a poster child for the Anthropocene, it's possibly that picture, is how do we get those two to coexist? And I'm not just talking about the displacement issue because that's the easiest one to see. The more difficult one to see is how do we get the left-hand side operating as an earth science in the same way that the one on the right-hand side is operating. So it's both displacement, but it's also systemic to get the urban environment as an environment to operate as an environment, where those elements, which are buildings instead of trees, become biotic agents. For those of you who would be interested in that, there's a whole bunch of theory supporting this: urban metabolism, systems ecology, resilience theory, circular economy principles. I'm increasingly having difficulty with the circular economy. I think ontologically it's challenged. But if you are interested in some authors that are working in the space, that would be well worth to pursue. But there's a couple of key points that you can take away from this up front. The first is replace what is displaced. The second is to embed cities within biomes as part of that biome. And I think that's probably the message I want to convey. The next is decentralizing authority because of the nature of the infrastructure. And in order to get that effective, you actually have to encourage local agency. The temporal stewardship was the one that's ironically one of the most difficult ones to do, simply because governments don't think long term, but you have to take a long time scale view to this. Then support all species, and the key word here, zoning for mutualism, which is what I'm going to talk about. So we want to shift from segregated land uses, which is what a typical zoning scheme would look like, where you have segregated land, you have residential, general residential, industrial, commercial, and they all form little independent worlds. And what you want to do is to shift that to what I call the urban forest analogy, where your city begins to operate like a forest would do. It is a biome. All biomes operate like that, whether it's a coastal dune one, whether it's a forest one, it doesn't matter. They support each other. And how do we get buildings to do that? There's some work that's been done in the space. One of the earliest protagonists of this argument, Lloyd's Crossing in Portland, has actually set targets for that integration process, going from an analysis of what Portland was pre-occupation, pre-settlement, where it is now, and where you can get it back to. But the interesting thing for me was looking at buildings as being mutually supportive. So the one in the center might be a hotel, the one on the right is an office, and then on the left there's another one which is behind the writing. And at different times of the day, they will be supporting each other depending on the occupancy rates. So using that, I've taken the old Athlone power station site. I know it's contested territory, but leaving that aside for the time being. A 35-hectare post-industrial site in Athlone, and trying to test, if we were to take this off-grid, what could we do realistically using a biome model? So it's Copenhagen climate zone. You can pull up its rainfall numbers, its wind speed, and so on and so forth, and inputting all of that into the site to get a sense of what infrastructure could be off-grid and what capacity could that begin to support. And the interesting thing is you start very early getting numbers around 5,000 residents that could in fact be supported off-grid on the site. And then the exercise becomes, so let's start sophisticating that. Let's model it for different scenarios, for conservative through to optimistic, based on different energy generating capacities and different energy technologies. And the number begins to float from 5,000 up to 10,000. And then you can take that to another level and says, well, now let's go for that mixed use. Let's not do it, there's some housing over there, and then there's a little shop there, and there's a little housing over there. 35 hectares is not a small piece of land. Let's select those land uses that will actually operate like a forest. And that was just unbelievable. A 32% reduction compared with segregated case in terms of sharing energy, and increasing precinct self-sufficiency by around 14 percentage points. By getting mutually supported land use, in this case building use, they're in fact putting in a factor of in terms of resource sharing. And we did that for the water as well. Then optimizing those land uses was even more surprising. The complementary typology mix, the ones that came out tops, school and supermarkets, 22% reduction in grid imports, school and retail, 20.2% reduction in grid imports, school and hotel, 15% points. And the fascinating thing to me was that just about every community has a school opportunity. So each community that has a school presents an opportunity for, in fact, putting in place a mutually supportive infrastructure. That's off-grid. The water one was even more staggering. Now, there's a rider here because Cape Town is blessed with something called aquifers. And the city does, in fact, have a very good managed aquifer recharge policy in place. So in the analogy again would be the battery for power, the aquifer becomes the storage for water. Okay? So it's the water battery, if you like. Okay? So using the rainfall to recharge the aquifer and then pulling that water up in summer, again, not new, Norman Foster did it at Reichstag in Berlin. Percentage improvement in water sustainability for the Athlone site is approximately 55.4%. Compared to independent building operations. So that's over 4.5 million liters of water that's available. And the significance of that is understanding that within the context of day zero in the city. How do you do that? There's a mixture of technologies. Those of you who are familiar with Koffenwaber, that was a test bed for a lot of this. Of rainwater harvesting and reuse through constructed wetlands, 5 different types of energy generating suppliers. So you look at all the range of off-grid technologies, including anaerobic and aerobic sanitation treatment plants, which is what Koffenwaber is doing. Putting that together, we have roughly, and then upping the standards. So we're talking of passive standards rather than national building regulation standards. Would provide service independence to people residents on that site of between 5,000 and 10,000 people, completely off-grid. I think that number can be improved and currently working on doing that, looking at things like car sharing, carpooling, using electric vehicles where the electric vehicle becomes a battery storage, including the buses, and then start factoring in things like even daylight saving opportunity. The interesting thing in the exercise is the figure kilowatt hour per square meter takes on a totally new definition. It's no longer just kilowatt, it's which kilowatt. Is it solar, is it biogas, is it wind? It's no longer hour in terms of how long, it's hour which time of the day. And it's no longer just square meterage, it's which square meter. Is it the school? Is it the residence? Is it the shop? So the modeling becomes very interesting in actually optimizing across a range of opportunities and technologies, most of which exist already. So this has got some serious policy applications. The first is having to rewrite our drainage regulations so that water reuse becomes an easier thing to do, recycling of water. Okay? Being able to sort out your black rain and blue water and putting it back. All of these things have got to become closed loops. Zoning and permitting frameworks. Every single zoning application that comes into the city can and should be viewed against its complementarity. To what extent will rezoning this piece of land from this to that make it possible for this precinct to begin to operate like a forest? It's not just do we need another shop, or do we need another office building, or do we need more housing? It's to what extent will this, in fact, fit into a picture where it's becoming mutually supportive. And in a way, we're blessed because our zoning schemes are generally dating back to the 1950s. And so almost every single development we do in South Africa goes through some kind of land use amendment. And each one of those is an opportunity to introduce complementarity, if we want. So in conclusion, integrative closed-loop design, complementarity, mutual support, treating buildings like biotic agents would give us that opportunity of solving that provocation. Can we deal with climate change and infrastructure development at the same time in a way that solves both problems? The answer is yes.
Thank you very much, Llewellyn, for those provoking ideas. It's always nice to model what can be done. The challenge is in doing it. Our next speaker is Dr. Henry Egugu. Henry is a researcher and lecturer at the Department of Architecture and Industrial Design at Tshwane University here in Pretoria. His work focuses on the nexus between policy and capacity development for fostering resource-efficient and green-built environment. He's also a research fellow at Project Drawdown USA, where he evaluates climate solutions mainly in the building and electricity sectors. He was a visiting international researcher at the University of Helsinki. And he will be presenting on developing resources and tools for industry decision support. Welcome, Henry. Thank you.
Good morning, everyone. I'm excited to be here and really appreciate the invitation. So I'll be talking about developing resources and tools to support industry professionals and decision making. And this work actually comes from some of my work from my doctorate, as well as the work that I do with Project Drawdown. I'd like to start first with the key takeaway from the presentation, and that is that people and policy are key levers to drive energy efficiency and climate resilience in the built environment. Supporting industry professionals and the collective decision-making process is critical for developing green infrastructure that mitigates climate change and enables a sustainable future. So a bit of background, we've heard about how much greenhouse gases the building sector is responsible for, and CO2 emissions as well. The built environment has contributed significantly to the growing electricity consumption over the past 3 decades. And according to the International Energy Agency, over the next 25 years now, by 2050, we're expected to see, massive increase in built floor space. And so all of this points to the issue that we need to scale up efficiencies so that we do not lock in inefficient buildings and lock in inefficient spaces. Now, within the energy framework or the energy efficiency framework, there are a number of components, and I like to phrase them in 4 ways. The first is the processes that are involved, and so you have your technical procedures, performance targets, whether that's for the SANS 10400XA or sometimes even our green building certification systems, all of that. We also have our products. So we're talking about services, the equipment, whether that's the HVAC equipment or the materials that we build, that we use when building our structures. Policy is another key component, of this framework. So we're looking at the protocols, the industry standards, and perhaps policy acting as the bridge between research and practice. However, one understudied, and if you want to say under-focused component of this energy efficiency pool is the people component. And so we're looking at stakeholders, the role of stakeholder supports, the roles of our clients who are at the end of the value chain demanding these buildings, or even the industry practitioners. And so to address this, I conducted a study, as I said, as part of my doctorate, where I engaged with practitioners, so industry practitioners, industry experts who are building energy simulation experts with over 300 years of experience. And they were commenting on the reality they face on the ground, because there's research, and that's what we find out. There's research, there's all the policy and frameworks that we have, but what's happening on the ground? What's happening, with clients? And so through that process, I identified 41 different industry challenges that they are facing, that if addressed would drive energy efficient practices. And I'm only going to share or focus on 3 main points. And first is that there's limited market pool, okay, whether that's for building energy performance and simulation, or even green building certification. There's a limited market pool, and that's driven mainly because clients question the need for it. I mean, they ask, okay, what do I need this for? Sometimes they even request it so late in the project. Design is decided, materials, all of that's decided, and we need compliance calculations. All right, let's get someone who does who uses Design Builder, does those analysis, and let's show that the building complies. Okay, maybe getting ahead of myself a little bit, but that leads me to the second point, where the focus often for building projects, focusing here in South Africa, really has been on largely aligning with your minimum compliance requirements and not necessarily being performance driven. And that requires a mindset shift, because there's no way we can really push climate action and ensure sustainable built environments if the focus really is on meeting the minimum requirements, and so that they say this building plan or that is approved. All right. So performance-driven approach to energy efficiency needs to become the core of our expertise in the built environment. And the last thing I'll talk about today on this is the need for capacity development. So that's retraining both the current and future industry workforce to ensure competency, to ensure climate literacy and resource efficient practices. And one of the ways that we've tried to address this at the Department of Architecture and Industrial Design at TUT, where I'm from. TUT is the Tshwane University of Technology here in Pretoria. Over the last 2 years, we've cooperated with the World Bank Group, the International Finance Corporation specifically, to train our students, our third-year architecture students, on climate literacy using the World Bank's materials. And so at the end of it, they go through the whole process, and then they are certified by the IFC as climate literate. And that's extra value that's given to our students, and we incorporate that into the curriculum. Now, this isn't always easy. It took us 2 years of follow-up, calls, emails, all of that to secure it. But because we believe in the need for capacity development, it was worth it. And, it's always exciting when I meet with the students, and they tell me how they love using the platform, how they're learning so much more about sustainability. I remember one student once submitted a project to a different lecturer, and the lecturer sent it to me and said, look here in the reference list. For the list of references on sustainability, the student just put my name as the reference at the end. So, that was funny. But it highlights where there's opportunity. So I'd like to conclude with a bigger picture, introducing the work that we're doing at Project Drawdown. We've heard about it today, but the world really is facing a climate crisis. And ultimately, we need more climate action, but not just any kind of climate action. We've been having that. What we need is smarter climate action. What we need, indeed, is smarter climate action. So the good news is that we can avoid the worst impacts of climate change by acting decisively as well as effectively. So introducing the Drawdown Explorer, which we like to call, and we believe strongly that it's the world's ultimate climate solutions platform. Now, this was recently launched at the New York Climate Week, late September, and we're excited about this project. So the Drawdown Explorer, as I mentioned, is a revolutionary new platform for climate solutions and strategies, and it provides the best available data for decision makers with key insights that can help climate action, localizing the intelligence and really to drive the effort. I'd like to point your attention here. So, does this work? Okay. The red dot is quite small, so you're going to have to squint your eyes a little bit. Okay, but really, it's a platform that contains a number of solutions that cuts across multiple sectors. So electricity, buildings, industry, transportation, even land use and oceans. And our approach here really is to look at solutions that either improve efficiency, so cutting emissions, cutting greenhouse gas emissions, or sequesters carbon. And so a lot of effort went into this, over 20,000 hours of research. Once the site is fully loaded, it'll have over 150 solutions that have been analyzed. And indeed, we're bringing the best science and data to the task of ensuring a climate resilient world. The Explorer brings climate intelligence to the here and now. And what you see here is we have, we're given a number of metrics, and all of this is interactive. And it's free to use. It's not paid. And as I mentioned, covers a global geographical scope. So in here we look at the effectiveness of these solutions. We look at the adoption. So how much of the solution has been deployed? For example, in the building sector, we have maybe insulation materials or something as simple as LED bulbs. You'd be surprised how many countries don't have energy efficient LED bulbs installed as the main thing in their own building sectors. For example, in the UK, this was still the recent data we saw that I worked on as well, was as of 2018, LED bulbs were less than 20% of what's installed in their homes. Most of it is still halogen bulbs, and that of course draws a lot of energy. So it's globally applicable. You see how much of how much of it has been deployed, the climate impact there, how much greenhouse gases it cuts, the cost implications as well, the speed of action. So is it something that is gradual? And then you see the climate pollutants as well, and of course, additional benefits. So a lot of information that has been well curated to make it easy to use for general folk. And of course, we are, as part of, let me say, for the nerds who might be interested in getting into the numbers, we make the spreadsheets publicly available as well on Zotero, so it's something that you can always cite as part of your work. Okay, so the platform, as I said, is designed to support real-world action, offering specific recommendations that's been tailored for a different range of stakeholders. And if you're a climate professional, regardless of what your field is, of course, here we have interest in the built environment, but you might know of someone else who is in a different field. I spoke yesterday with some people from, I think the CSIR, yes, who are doing in the field of mining and all of that. And so this helps us unlock and accelerate solutions through your unique resources, your unique networks. For more information, please visit the Drawdown Explorer. So that's drawdown.org/explorer. And if you'd perhaps be looking to get in touch with us, info@drawdown.org. And you can also, I'm also on LinkedIn as well if you need to reach out. Thank you very much for your attention.
Thank you, Henry. Wow. There must have been a lot of work that went into that. And I'm sure you could have spoken a lot longer digging into all of that detail. But thank you for sticking perfectly to time. Our next speakers, we have a duo, Letitia van der Merwe and Wynand Prol, based on Wynand's master's research at the University of Pretoria. Letitia has over 20 years' experience in the property development sector and currently hails from the University of Pretoria Department of Construction Economics, where she lectures. She has a PhD in real estate and a master's degree in research psychology. She's an accredited Green Building Council professional. She is a member of the South African Property Owners Association and a non-executive director of the BIM community in Africa, so very active. And Wynand comes from Nedbank. And you're going to be asking, what is a banker doing speaking here? Well, he's about to tell you. We're very excited to hear about your research and looking at risk in the built environment. Over to you. Thank you.
Thank you so much, Corinne, and welcome everyone. So our approach is completely still on buildings. That's our common denominator, but we're looking at it from the financial sector now. And what we're saying is that climate change is no longer just an environmental issue. It is also now a financial issue in South Africa. We're already seeing how extreme weather events like floods, we saw in KZN, And the fires, for example, in Cape Town that destroyed so many of our heritage buildings are exposing the limitations of insurance for affected assets. And assets, when we refer to assets, we mean buildings. Okay, that's our assets. So looking ahead, this could pose serious challenges to traditional credit risk models that the banking or the financial sector uses, especially when insuring the asset or its income stream. That can become prohibitively expensive. So our study bridges the environmental science and finance by using geospatial data to evaluate climate-related risk in commercial property finance. What makes our study different is the focus not only on portfolio level trends, but also specifically on asset level risks, so on each property. We aim to support the resilience lending practices by integrating geographic context directly into financial decision making. And just very recently, in July this year, the regulator, this is the Bank of International Settlements, issued their working paper where they calculated risk-weighted assets models adjusted for physical climate risk, potentially increasing risk-weighted assets between 15.5% and 22%, which will require increasing capital requirements for banks. So another interesting yet quite intuitive finding is that diversification benefits portfolios shrink and many borrowers are hit by the same climatic event, flood or whatever that may be.
Yeah, so the problem is that although these climate risks are already embedded in valuation and lending practices, they seem to be quite inconsistently applied. Most of the models are static, they're retrospective. They don't really forecast income disruption and asset value sensitivity into the future. And where they do, it's mainly portfolio-based, and that it lacks that granularity for those key risk asset level metrics like debt service cover and loan to value, which in extension has an impact on the probability of default and the loss given default of those loans, which then affects that risk-weighted asset that the BIS has obviously investigated. So these models also often exclude the future insurance availability metrics, different cost paths, and geographic climate interactions. So this could obviously then result in underestimating of that income volatility and obviously borrower distress, especially in those high-risk zones.
Okay, so the method we used, we conducted an exploratory study using data from the commercial property financier and from a GIS provider. Rather than looking at the geographic factors in isolation, we deliberately used a simplistic multi-regression analysis so that others can easily replicate our findings. Our model included variables like elevation, slope, proximity to water, lightning density, and fire station access. We then assessed how these environmental risks impact key financial metrics such as the replacement value of a building, market value, and the net income of that property. We also integrated ESG principles, specifically the environmental pillar, the E, into our spatial analysis. While we didn't recalibrate for probability of default and loss given default models, our approach lays the groundwork for future integration into capital adequacy and risk-weighted asset calculations.
Yeah, so we first looked at a flood risk model. So we obviously had a portfolio of about 3,600 odd properties where we could then overlay some of these geographical data sets. And what we found is that flood risk isn't just about obviously being near to the water. It's also shaped by elevation, slope, and terrain orientation. So we built a regression model, and it was moderately accurate, but very informative at an R-squared of 0.45 with an RMSE of 2.35. We also highlighted that future enhancements could include vegetation, soil type, and infrastructure data into these models. We also see the potential in machine learning techniques like random forest regression to improve the predictive accuracy and scalability of these models. We then did a fire risk model, and the fire risk was influenced mainly by property age, proximity to fire stations, lightning density, and historical fire events. The model performed even better with an R-squared of 0.65 and an RMSE of 1.68, indicating strong predictive accuracy. We found that both natural and built environment factors interact to shape fire risk, and further improvements could include vegetation type, fire break presence, and seasonal wind patterns as that data becomes available. When we scaled our models using lettable area, obviously onto the value of the property, the replacement value, the market value, and the income. We specifically looked at the income prediction, and our models had an R-square of 81.2%. So this indicates that current valuation methods do incorporate and show that flood and fire risk specifically affect current replacement value, market value, and net income, even though none of these reports included any forward-looking statements. Now, fire risk, intuitively, it correlated negatively with the property value and income, as it is associated with higher insurance and maintenance costs. Flood risk, interestingly, mostly correlated positively, especially where flood defenses and scenic amenities are in place. It appears people will take on the risk for a beautiful view of the water.
Okay, so we recommend some mitigation strategies then, and we ask what can financiers do and property owners and property investors do. And the first is that they should really improve the financier side, the risk models, by incorporating environmental, social, and governance metrics into those models. Secondly, to invest in physical upgrades, and so specifically property owners, but it could also be with insistence from financiers, like, for example, permeable surfaces, catchment ponds, vegetation buffers, and also fire buffers and barriers. So these aren't just environmental improvements, they become then financial risk mitigators. We also recommend that a composite geographical risk scoring framework should be used, and we developed a framework like this, and that brings together multiple indicators, not just for portfolio level analysis, like most often done, but also for individual property level assets, which is often overlooked. That gives lenders a much clearer picture of climate risk where it really matters, on the ground, asset by asset. Further, our recommendations are that financiers adopt geospatial models for credit risk and align with the South African green finance taxonomy, and also with ESG-linked lending that should reflect forward-looking geographical risks, not just current risks, as this will also allow adjustment for loan terms and interest rate increases and so forth accordingly. Then collaboration is key, especially with municipalities, with insurers, and with environmental agencies. So data sharing can unlock smarter and more adaptive lending strategies. And this aligns with the regulatory environment, like, for example, the Sustainable Finance Roadmap and the Prudential Authority's climate disclosure guidance. Lastly, to wrap up, our geospatial environmental risks are financially material. Integrating forward-looking ESG principles at a portfolio level and at an asset level into credit risk frameworks will allow for the enablement of a more proactive climate resilient framework. The study then supports the shift from a reactive to an anticipatory lending strategy that helps to build a transparent and future-ready financial ecosystem. Methodology involves and as it grows and evolves, it can incorporate social and governance dimensions as well, as ours only looked at the environmental. And this would contribute to a climate resilient financial sector in South Africa and beyond. So our full paper will be available early next year because Wynand must go present now our findings in Rome at a conference in Italy, and that is on geographic perspectives on climate change mitigation, and then afterwards that would then be published. Thank you very much.
Thank you so much, Wynand and Letitia. Thank you for bringing that important perspective on infrastructure. As an architect, I think of what I'm building and how it looks and what it should be made out of, and I don't often think about the financial risk aspect of it and where I should be building. So thank you for bringing that to us. Our next speaker is Koen de Ridder, all the way from Belgium. Welcome. Koen is a senior researcher at VITO. VITO are important stakeholders in this conference, as you may have noticed. He is working in the Environmental Intelligence Climate Impacts team at VITO. He holds a PhD in climate science and has over 25 years of experience in urban climate modeling and monitoring. He's the main developer of the UrbClim model. Did I get that right? Which is widely applied to study urban heat islands and stress in European, African, and Asian cities. He will be presenting on cooling African cities. We look forward to your presentation. Thank you.
Okay, good morning, and thanks for the introduction. My presentation is about actual green infrastructure, so the physical side of the story. It's about urban trees, urban vegetation, and the question I'm asking here is whether urban green infrastructure can actually cool African cities. And I do understand that is a bit of a provocative question because we all know that vegetation does cool, and quite efficiently so, but still I think there are several aspects or several perspectives in this story which require some caution about what exactly we are understanding by cooling, because cooling is not just air temperature, as we will see, there are many other elements to it. We've been working on and off on this issue for 20 or 25 years at VITO, mainly in Europe for most of the time, but since about 5, 6, 7 years, we have turned our attention to Africa, and we've had several projects working on this, and I'm very happy to acknowledge collaboration with ACMAT, African Climate Center. They're around somewhere here, they're participating also. I think they're not in the room, but they are in other sessions probably. And then 2 NGOs, the Young Volunteers for the Environment and PlanAct. PlanAct is based in Johannesburg, and we've collaborated with them in Johannesburg also. And so this is a very good collaboration. And the city of Niamey in Niger has also been participating in projects that we have been running in the past 5 or 6 years. Now, there are several good reasons, I think, for our shift from Europe to Africa. I think one of them is that the heat stress in Africa is obviously much worse here. Africa is hosting among the hottest regions on Earth, and climate change is not going to improve that, of course. But there's another compelling reason, I think, that is, I'm sorry to say, but making Africa an interesting case to some extent, is that since we're talking about urban green infrastructure, it's important to realize, and you know that better than me probably, but growth in African cities is tremendous. And some studies even, they will put some of the biggest cities in the world in Africa towards the end of the century. I think these projections are maybe a bit exaggerated, they're perhaps not feasible, but still it is obvious, I think, that from all the continents, that Africa is still growing the fastest, and the growth, I think, will take place especially in cities. And so cities turn towards vegetation very often as like an obvious way of trying to improve their local climate. This is an impression of the center, or the central portion of Niamey in Niger. And it's quite green, as you can see. But then if you look at another area, also within the same city, Niamey, you see it's completely devoid of vegetation. And so now they have, or they try at least to create programs to enhance the abundance of vegetation also in these areas. But then I think it's important to really understand properly how vegetation works and in which sense it achieves the cooling. And that's what my presentation is mainly about. I have to start with a deception, and maybe some of you will know that, but the effect of vegetation on air temperature is very small. Typically, like the study shows, but we've been running monitoring campaigns that completely confirm this. Typically, trees, they will reduce the air temperature by something like 1 degree Celsius, maybe a bit more, sometimes less. And so that's not a lot, of course. Huh? Knowing that, for instance, with climate change, we're facing several degrees extra. Knowing also that cities are warmer by a few degrees, then trying to reduce it by say 1 degree by putting a lot of vegetation may not be very interesting. On the other hand, trees do have a very strong effect on other components that determine heat stress, specifically on the more radiative sort of components. In this article, they're talking about the mean radiant temperature. That's some sort of aggregated indicator that expresses the effects of both shortwave radiation and longwave radiation. So shortwave is the solar radiation, and the longwave would be the heat radiation that, for instance, comes off a hot wall, a wall that has been exposed to solar radiation then during the daytime and still radiates a lot of heat even after the sun has gone. So I brought a few examples of the strength or the importance of this radiative effect in the thermal part of the spectrum, so in the thermal infrared. And what you see here is on the left-hand side a thermal image taken with a specific or dedicated thermal camera. And on the right-hand side you see the same image but in the visual as a sort of reference for what you see on the left-hand side. And this is a picture taken in Johannesburg a few years ago. And you see this small building with a green roof on it, and part of the roof is in the sun and another part is in the shade of a tree. And if you then go and look at the same locations but in the thermal image indicated with the A and B boxes, you find that the temperature difference is 25 degrees. So that's a whole other story, from 1 degree to 25 degrees. I'm not saying that this is 25 times worse than 1 degree temperature change in the air temperature, but still I think it's quite evident that these are much stronger effects. And you can imagine also that for the indoor climate of such a small building, this makes quite a difference. This is another example from Niamey in Niger. You see a street view here with some shaded portions and some parts in the sun. And you can see that the temperature difference there, again, is about 15 degrees. And I think even that the color scale is not covering the full range. So it's probably rather something like 20 degrees Celsius difference between the shaded and the unshaded parts. And to wrap up a bit this story of air temperature versus other components of heat stress, I think it's important to realize that there are several components apart from simply the air temperature. So air temperature and humidity are modestly impacted by urban green infrastructure. Green infrastructure has some effect on ventilation speed, but not that much either. But the biggest effect and the biggest benefits you can hope to get from urban green infrastructure is really from the solar and thermal radiation components that contribute to heat stress and exposure. And realizing this, we turn towards monitoring. So initially we just monitored climate in cities with like standard air temperature measurements, with very like professional grade climate stations and everything, so it was quite accurate. And we were of course disappointed to find very small effects. At the same time we were also modeling, and also from there we learned that even if you replace like 20 or 30% of your built environment with vegetation, which is not realistic of course, but still even in such a drastic situation you would only gain maybe half a degree or something like that. So, and realizing that these other components that determine heat stress are much more important, we turn towards monitoring with the device you can see on the right-hand side. So this measures the wet bulb globe temperature. It's a very technical item perhaps, but it is simply measuring all of the components that I showed on the previous slide. So it's measuring air temperature, traditional sort of air temperature, humidity also. But specifically this black globe you can see there is collecting radiation, both short and long wave, and integrating that and converting it into some form of temperature also. And so we've been using this a few years ago in Johannesburg and Ekurhuleni in collaboration with this partner Planac that I mentioned before. And it's quite a simple device. It's rather easy to manipulate, and it constitutes really a nice sort of device also to use in combination with a community-based approach. And so we wanted to have, or to sample many areas in the city, or in different neighborhoods in Johannesburg and Ekurhuleni. And so, it was good to have like these teams of volunteers that helped us in collecting these measurements. The same thing here in Niamey. So there we have been working with the Young Volunteers for the Environment with a similar sort of device, and you see again the black globe. The same again, but here you see the strategy that we've been following to try and identify the effect of urban green space, which is that we typically measure with two devices, one in the sun and one in the shade, and just separated maybe by 5 or 10 meters. So basically exposed to the same environment, apart from the fact that one would be in the shade of a tree and the other not. And this is again the same, but more like a synoptic view. So you have again on the left the fully exposed WBGT device, and on the right the same device but in the shade of a tree. And that is typically what would come out then. So this is just one example of tens of measurements that we have been doing. So it's showing the WBGT, so these heat stress indicators during the course of a day. This is for one location in Niamey, in Niger. And it starts measuring around 9 o'clock until the end of the day, 5, 6 o'clock. And the blue curve represents the measurements that come from the climate station, or this WBGT device in the shade of the tree. And the red one, obviously, then measuring in the full exposure of the sun. And you can see that while they start both in the moderate category of heat stress, that the fully exposed device very quickly goes to strong and very strong, and even far into the extreme heat stress, whereas the blue curve remains within the, let's say, the strong category. And that is bringing me to my conclusion. So the question initially was, can green infrastructure effectively reduce urban heat stress? And the answer would be, based on our experience at least, the answer would be yes, but only with very site-specific and dedicated implementation of green space. And also when you want to monitor the effect of green space, it's really important to use the correct metrics and not just rely on the simple air temperature. And finally, as I've been mentioning before, using urban green space as a sort of diffuse measure, putting a little bit everywhere and hoping that the air temperature will drop by 5 degrees or so, that's absolutely not realistic. And so again, I think it's important to realize that this local effect of green infrastructure and to use it accordingly in adaptation plans. Thank you.
Thank you very much, Kun, for that interesting perspective. Our final speaker is Dr. Ida Breert from the University of Pretoria, Department of Architecture. She's a registered professional landscape architect. Her research considers space design and how it relates to natural and cultural contextual issues and local identity in sub-Saharan Africa. She demonstrates the importance of landscape designers in shaping green infrastructure, urban ecology, and social ecological systems. She'll be speaking to us this morning about co-creating microscale nature-based designs. Thank you very much, Ida.
Thanks, Coralie. Thank you. Good morning, everyone. I'm very excited to be here, and I've been enjoying the speakers before me. So I also think thanks for the organization and the linking in of the presentations currently. So this morning I'm talking about our project's CONSIS, a research project on microscaled nature-based solutions. I want to show some examples of what we've been doing in terms of co-creation, and then also some discussion points at the end. Green infrastructure in the city of Tshwane leaves much to be desired for, from sealed surfaces to disparities to encroachment, and then also the degradation of existing and unmanaged green spaces in and around our city. Although we know the benefits of green infrastructure, and thank you also for the reminder and presentation, Koen, on that, but and a lot of this is written into policy documents, we do find that not a lot of that is actually happening on the ground. So our project has been running since 2021 with a follow-up project starting in 2023. We work with the Ministry of Foreign Affairs in Denmark funding the project between the city of Tshwane and the University of Pretoria, University of Aarhus in Denmark. And we're looking at the transformation of blue-green urban landscapes in the city of Tshwane, and then nature-based solutions and collaborative learning. Our work package specifically looks at design experiments and also communities, although there are many different aspects of the work in different research packages. We work in Mabopane, which is in Region 1, and it is on the Sand River tributary that we are looking at this unmanaged green space. A lot of dumping has been happening in Mabopane. It has grown over 300%, I think, in the last 30 years in terms of urban growth. And you can see there also the deterioration because of mostly building material dumping practices, but also solid waste. There's also sewer leaks into the Sand River tributary, and that all affects the river quality and the environmental quality on that site. We started working with students in 2021, and we've mostly assessed the quality of the site and the issues and the problems around the site. All of this is published, so you can also find that on ResearchGate, all open access. We looked at values, activities, benefits, costs, and risks around this green space. And we also worked with the city of Tshwane, trying to look at how to shape policy and spatial frameworks in terms of principles. The principles that we came up with at the end of the day is that we need to have better access to our green infrastructure assets, also cross-sectoral partnerships to try and fund and manage these spaces, co-ownership with communities, co-management that needs to take place, but also protecting the spaces by engaging with it, not fencing it necessarily. Our work package then on CONSIS look at these nature-based microscale installations. We look at environmental improvement, but also skills transfer, environmental awareness, capacity building, and then uptake and upscaling, hopefully. There's been different phases. We looked at the status quo, then we did community co-centered design in 2024, then went into co-implementation this year, and then co-management 2026, the project ending in 2027. I'm going to show you some images of the work since 2024, the co-creation process. So we spent a lot of time trying to understand the needs around the green space, the issues, and we also leaned on local knowledge involving children, but really speaking to the local community, working with honors students in architecture and landscape architecture at the university. We then started to formulate little microscale projects that could actually address the issues in and around the site, and work with the community to design those. The students then presented this work. We selected between the community, the municipality, and the researchers 3 projects, kind of 3.5, 4. And we looked at the northern side of the site, which has got a closer or finer knit grain and is better integrated with the green space. These were the areas we considered then for the implementation of the projects, specifically also looking at the crossing, which you saw from the air, that is also used by a lot of people. Specifically, the projects that were chosen looked at erosion control by using the dumped rubble on site, looking at composting the green waste that is dumped on site, and then creating little shade structures where people could have knowledge hubs or sharing or getting together. And then lastly, looking at propagation of plants, medicinal or other useful plants in the area. We planned about 7 workshops for the year. This year, we've already had more than 15 workshops, mainly looking at raising awareness, promoting sustainable practices, encouraging critical thinking, but also taking responsibility somehow from the community side on their own environment. This was the vision for the little prototypes that we had in mind. We advertised in the community, so it was free for anybody to attend and get involved from the community side. Usually we would have 2 to 3 hour workshops, some information sharing, and then also meals that went along with it. We started off at the beginning of this year by putting up signage that came from the interviews held with community members, where people themselves expressed the desire for a cleaner and better environment. This kind of kicked up the implementation phase. We also worked with the City of Tshwane Region 1 representatives in cleaning up the area with waste, also stormwater, and other departments like environmental education. Here we are doing some plant propagation, showing people how to grow plants from pieces of other plants. A steering committee was established in March, also by desire of the community to steer themselves, hopefully after the project. We then worked on composting practices as per the students' examples, the Gabion structures that would also be there to actually bar off vehicles that come and dump on the site, and then more plant propagation requested, a bit of feedback all the time to the rest of the community from those people involved, and then generally getting between 40 and 120 people attending these workshops, tree planting with a nearby friends group, and then finally arriving to the shade structures, which is a construction component. And as per our project, although there's been a lot of benefits shared, this would actually include employment and financial stipends to people involved in the project, and trying to then also rotate and really share the benefits among a community that is highly unemployed. This unfortunately led to a lot of problems for us, a lot of agendas and a lot of struggle about who is involved. We found a lot of very creative people on site, and in August we also worked on the stormwater bioswale creation in conjunction with cleaning up stormwater outlets on site leading to the river, and then also showing people how that would function. There would also be still a component before the end of the year on rehabilitation work and alien invasive removal, and all these workshops go along with information sharing, conversations, collaboration and collaborative learning and awareness. And the steering committee more and more taking over, despite also a lot of internal conflict there. So we left with a bit of the end of the year still, and then adaptive co-management towards next year, where we also want to put up a lot of signage and also share a lot of processes in terms of webpage links and so forth to keep the knowledge flowing. And so those were the different key points that we looked at, the research, design, community empowerment, green space improvement, partnerships, but also institutional strengthening by trying to establish this committee. We faced the following issues along the way. Firstly, we had a lot of legal barriers. Everything that we have done on site is basically illegal. We do have a partnership with the city in terms of a MOA, and we do also converse with the city constantly, but at the same time there is no way leave agreement, there's no lease of land agreement. Although we have started the processes, it takes an immense amount of time, and that also creates a lot of uncertainty. There's also policy barriers. Although you are allowed to adopt spaces and clean it up, you are not supposed to get any benefit from that from the city side, and we find that also quite problematic in taking this forward or upscaling this. Financial barriers, we found that there's a lot of struggle around benefits, although we really we're very, very reluctant to share monetary benefits other than meals and knowledge and skills. We did find at a point that it was necessary, and it did create a lot of problems for us. At the moment, what is happening, and as you can see on this image, we are working in Ward 20 although most of our residents that actually border our sites and the red circles live in Ward 22, but according to the councillor, only Ward 20 people may take part and get stipends on the project, and she has been able to put enough pressure on us to actually have this regulation serve on site and make a lot of people very, very unhappy. So it's been quite tense. We've learned a lot. We learned a lot from the community. We also learned a lot about social processes and structures. But the project is not finished. We hope still for more uptake and also showcasing and inviting other communities to come and see what has been established. As you can see, it's very low key, it's very low tech. It's basically working on what we know and trying to create ownership and small-scale solutions that can actually make a difference on a day-to-day basis. Yes, you can also consult the webpage to see from time to time there's updates. There's also a lot of the work that I've shared is on there, and all the journal articles are available on ResearchGate Open Access. And you can also contact me at the University of Pretoria if you are interested in more information. We will be also publishing the work that we're currently doing in the next year or two. Thank you.
Wow, thank you, Ida. That was a lot to get through in exactly 12 minutes. Thank you so much. Folks, that brings us to the end of this session of speakers, but we have 4 minutes left for questions. I think it's been a great spread of presentations showing us that there's not one silver bullet to answer this question of climate change mitigation, and we need to work together so that we can come at it from all the different angles. But let me open the floor quickly. Any questions? I'll just hand you the mic.
Thank you to the speakers for very enlightening presentations. My name is Vishal Harichand. I work for the South African Forestry Company. My question relates to the policy gaps that are hindering forestry's inclusion in green infrastructure frameworks. And how can an SOE like SAFCOL help to address some of those policy gaps?
I think that question is directed at Llewellyn. You wanted to speak about forests.
With great difficulty. I find your position very interesting. About 6-7 years ago, we were working with SAFCOL to look at waste and turning that into a construction material, which would obviously improve the whole value chain of forestry. The difficulty is at that policy level. One of my people I really admire is Jeffrey Sachs. And he makes the comment about how governments are either reluctant or incapable of taking a longer view. And for as long as that is around, your policy is going to reflect that. So I don't have an answer for you, which is why I'm kind of ducking and diving. But it has to start with a longer-term vision for the country and then putting in place what is needed. And we see that in construction around building standards, for example. When the pressure was on Eskom, that kick-started energy efficiency building regulations. So that becomes a driver for policy. Perhaps you need to find that trigger that would actually make the policy then flow out of the challenge rather than try to put a policy in place and try and convince them there's a challenge.
I must say myself, the more I'm looking around lately, the more I'm seeing biodiversity and the built environment coming together, and we need to work together. Those of us in the built environment and those in the forestry and other environmental sciences, we need to come together much more. Maybe one more question? Peter?
Yeah, I didn't understand that question. I would like to, though. So can I ask that gentleman to explain his question?
Thanks. I think the gentleman actually put some light bulbs in my head, because we as an organization are looking at how we can diversify in the forestry industry and also create a case for change. Create a case for change. And as a state-owned company, we feel we can do more, but we don't understand what is it that we can do more, whether it's policy, whether it's regulations in terms of the use, the full use of the tree, for example, in construction. We do know that we produce the logs and the lumber that goes into building, but we feel we can do a lot more, either with waste material, etc. And yeah, so that's really where the... but maybe, we can talk after that, yeah.
Our time is up. Have you got a short question? Okay, is it a yes/no question?
Thank you very much. My name is Siabong. I'm part of the CSIR family. I've got two questions. One for Dr. Peter. Do you think that South Africa is on track with the net zero emission by 2050? The second question is for Dr. Igugu from TUT. The Drawdown Explorer platform, is it an open source?
Yes, fully available. Spreadsheets are also fully available.
Thank you very much, because we're already paying more on electricity.
We are not on track for net zero by 2050. Time is running out. We need to work hard. Folks, thank you very much for your attention this morning. We are available for questions. Please come and chat to us. I know that we can talk all day about these things. But so let's go and have some coffee and talk some more. Thank you for your time and enjoy the rest of the conference.